Okay, we're now we're on. Okay. All right, so today we know the definition of the tangent is the sine of theta over the cosine of theta. But how does that graph turn into that thing that goes like this? Okay. Yesterday we did the sine and the cosine, right? So how does the graph of the tangent, why does it look the way that it does? So that's what we want to explore today. Okay, so we said we base everything off of definitions. Okay, the definition of the tangent of theta is that sine of theta over the cosine of theta. Okay, we didn't think of that. That was decided a long time ago that we're going to have this thing called the tangent of theta, and it's going to be defined as this. It turns out that it's kind of useful for lots of different things. But there's another definition of it that you probably haven't seen before, and that's what I'm going to try to show you today. So we're going to start off with a circle. But this time, we're going to approach the circle from a little bit different angle. No pun intended there. Now, what I want you to imagine is, a line that touches this circle just at one place, and the one place that it touches is at the 0 radian mark. Okay? It touches the circle only one time. So what does that line have to look like? Yep, it's got to be a vertical line. So we're going to draw ourselves a vertical line. Bless you. Here, Mrs. Rosing's niece. Whew, that's probably the best line I ever drew. Let's just take a moment right now. Okay, what do we call that line? What's special about that line? It's the tangent line. Okay, so this is a line that is tangent to the circle. Okay? So I wonder if it produces anything fun for us. Well, let me show you a couple of things here. So now, you know, we've got this radian that we use, and so we have 0 radians is a point right here. That's how long 0 radians is. It's just a point. Remember that a point is actually it has no dimension whatsoever. It doesn't have a length, a width, a height, or anything. It's just a place in space. So that's where it is. Now, if I go up, watch this. If I go up, and I'm going to stop this thing at pi over 4. Okay? I'm going to stop this thing at pi over 4. Pi over 4 radians, that is. And then what I'm going to do is I'm going to draw another line, and it's starting at the origin, and I'm going to shoot out the line, and it's going to go straight through the pi over 4, but it's going to continue on, and it's going to hit the purple tangent line. Okay? So here I go. Love that. Okay. Okay. So that's all nice. Okay. What just happened? What do we notice here? Someone said it already. Pardon me? There's a triangle that is formed. Everybody agree? You learned somewhere along the line that tangent lines are unique to a circle because when they touch, they're actually perpendicular to the radial segment that comes out. Okay? And so there's this triangle. Anything special about the triangle? It's isosceles. What does that mean? Two sides are the same. How do you know that? Because okay. We got 45 degrees right here. That's a 90. That's got to be 45 as well. So what we have here is a triangle which is half of a square. It's a 45, 49 triangle. So radius of this thing is 1, right? The circle, we defined that a long time ago. Okay, this is our unit circle. And so how long is it from here to here? 1 unit. Okay, anybody recognize that as anything? Anything special? Backboard. See this right here? We did pi over 6. On the previous one, no, there it is. Tangent of pi over 4. So what's the awe about? What do you see? Somebody put it in their own words. The tangent is the length of the sides of this triangle. Agree? Okay. So let's do another one. Okay? So let's go further up the line. Let's stop at pi over 3. Okay? So I'm going to stop at pi over 3. Okay? Then I'm going to do the same thing. I'm going to draw my little triangle. I'm going to get rid of this just so it doesn't get all messy. And now I'm going to shoot through that pi over 3. I'm pleased by simple things. Okay, so now I get rid of that 45 there. All right, so now what do you notice? What kind of triangle is that? It's a 30, 60, 90. Okay, how do we know that? Well, because that's pi over 3, we know that the angle measure that goes up on pi over 3 radians, this right here, is 60 degrees. Okay, so it's a 30, 60, 90. Okay, so what else do we have here then? We have another triangle. This length is 1. Okay, do we know any of the other lengths? The hypotenuse is 2. Remember that? This is from our talk on the equilateral triangle. Can you see the equilateral triangle hidden here? This is half of it, then the 1. Okay. Then what was this length over here? Turns out that it's the square root of 3 times whatever this side length was. Okay, and that's what works. So we could prove it by Pythagorean theorem. So this is actually the square root of 3 as the length from here to here. Okay? All right. Is that anything special? Tangent? Tangent of what? Let's try it. This was pi over 3, so watch this. The tangent of pi over 3 is equal to the sine of pi over 3 divided by the cosine of pi over 3. Okay, so let's do a little math. All right, you guys are professionals now on the sines and the cosines. So what is the sine of pi over 3? Good. Square root of 3 over 2. And what is the cosine of pi over 3? It's 1/2. What is the square root of 3 over 2 divided by 1/2? Square root of 3. the tangent of pi over 3 is equal to the square root of 3. Tangent line, good. Okay? So, somebody draw the conclusion. Can we draw a conclusion yet? Is the y-axis of the triangle, the tangent is the y-axis on the triangle? Anybody want to add to that? Say it a different way? It's the height of the triangle this way? Okay. So whatever we want to find is the tangent value. All we have to do is start at the center, shoot through that radian value, hit that tangent line, and the distance from here to here is the answer to the tangent. Okay? It works every single time. So, by the way, there's another one. If I go through pi over 6, that's the other magic one. Okay? Then I got this distance right here. Okay? What is the answer to that one? This is at pi over 6. That one's on the back there. We did that somewhere, didn't we? Bottom left. Square root of 3 over 3, which is the same as 1 over the square root of 3. Okay, so this one's smaller. This is the square root of 3 over 3. Square root of 3 divided by 3 is a third of the length of the square root of 3. Is it possible to figure out what? Let's see. We know an angle. On this one, we just know it as a 30, 60, 90. And the problem is we only know one length of one side. You could use the law of sines, though. Sine of 30 over this is equal to the sine of 90 over... No, we couldn't do that because we don't know that one. Okay. Now, so what would this start to look like if we were to graph it? Okay, now picture this. So now I'm going to start graphing the tangent function. So this is my theta value. This is my y value, which is the tangent of theta. And I'm going to go out. So I'm going to start at 0. And I don't know, I'll go up to pi over 2. See what happens. So here's pi over 2. Okay. So I'll make some marks here. 1, 2, 3. We're plotting the tangent based upon that definition. So what is the tangent of 0? It's 0, isn't it? How tall is that tangent line? It's 0. So the tangent of 0 is 0, always. Then we're going to do a couple of these other ones. Here's, if I go a third of the way over there, so this is pi over 6, pi over 3, and then pi over 4 is halfway here. Okay? All right, what was pi over 6? Square root of 3 over 3, how big is that? Give me a decimal number that's about right there. Square root of 3 is about 1.7. Okay. So 1.7. So divide that by 3, that's about 0.6. So I'm at about 0.6 right here. Okay. Tangent of pi over 4? 1. Tangent of pi over 3? About 1.7, that's the square root of 3. Okay? So it's starting to do this little thing here. What happens after this? The longer, the closer, the further I move and start cutting into this circle as I go this way, how long does that line, how's that line doing? Move a little bit here, doesn't it get a lot bigger there? Okay. So it's going to start going up. Okay, what happens when I hit pi over 2? It's parallel. So does it ever touch the tangent line? No. So that means there is no value. Therefore, what happens here is this goes up and up and up, okay, until we hit pi over 2. And at pi over 2, it doesn't touch. And in fact, if you punch in your calculator, tangent of pi over 2, make sure you're in radian mode, it's undefined. You can't get a value. This is the reason why it's undefined. Okay? Okay, let's keep going. We'll hop the fence, go on to the next values. Okay? So what happens as I go towards pi? Okay? So I'm here, then I'm here. This is where it's parallel. What happens when I go here then? Does it touch? Yeah. It touches, but it's negative. Love that. Okay? So what happens here is it comes from negative infinity, and then it goes all the way to 0 as we move into the second quadrant. So that's why the tangent starts then down here. Then it does this thing up to 0. And what is the tangent of pi? 0, because it's the horizontal line. Make sense? Okay. What happens if we keep on going again? Pi over 2, and then we're going to go. Don't tell me that's us. Son of a gun. Okay. I wrote down the problems. We're going to keep on doing those. Start working on the next one.